This histological slide is stained with something called Masson's trichrome stain. It's 3-in-1. With this stain, collagen appears to be blue, but whoever did this slide really stained it. And so it's like collagen's like a dark teal color. And muscle stains a very, very dark red. This slide shows an artery with its very, very round lumen on the right and a vein with its collapsed lumen on the left. In arteries, the tunica externa contains a lot of collagen fibers, and you can see those collagen fibers around our artery over here on the right. These collagen fibers, they secure arteries to the surrounding tissues. Especially in arteries that are close to the heart, there's a lot of expanding and contracting to take the pressure from the pumping of the heart. And therefore, it's important that these arteries don't move around too much. Although the tunica externa of veins has those same collagen fibers for attachment, the tunica externa of veins also has a lot of elastic fibers and smooth muscle. The elastic fibers allow veins to change the diameter of their lumen and make their vessel larger or smaller. We don't see that much with veins. I mean, they're capacitance vessels or reservoirs mostly, so they're never really full. But for example, during exercise, a lot of blood is returning to the heart from skeletal muscle, and the veins need to be able to accommodate that blood volume. They need to be able to expand. Recall that veins return blood to the heart and are very far away from the pumping action or the systolic pressure produced by the heart. So the smooth muscle in the tunica media of veins, it allows them to contract and relax in an effort to move the blood along and move it back to the heart. But the large vein that leads directly to the heart is called the vena cava, and the vena cava is so large that in the tunica externa, the vena cava has its own vessels that are serving the smooth muscle of the tunica media. It's almost as if the vena cava is so big that it has to take blood away from its lumen. And the vessels that are in the tunica externa, the extra vessels of these very, very large veins, are called the vasovassorum, which is a phrase that literally means vessel of the vessels. Like you couldn't give that a better name? Vessel of the vessels. The tunica media in both arteries and veins is just sheets of smooth muscle. There's no tunica media in capillaries, just arteries and veins. In arteries, there's a very thick layer of tunica media. And as we said, the arteries closest to the heart, like the aorta, although incapable of contracting, they still have a pretty good amount of tunica media so that they can contract to maintain their diameter. In the tunica media, where it meets the tunica externa, in many of our larger vessels, there's this extra elastic lamina that's called the external elastic lamina. And you can see that here and here. And we'll just label it as external elastic lamina. The tunica media in all of your blood vessels is sympathetically innervated. And this means that the nerves that control the tunica media are coordinated with a sympathetic response or a fight or flight response. When someone tries to steal your fanny pack in a dark parking lot, you get an adrenaline rush. And an adrenaline rush is just the release of epinephrine from your adrenal glands. Epinephrine is capable of contracting all of your tunica media, squeezing blood into your skeletal muscles so that you can run away from the person stealing your fanny pack. The tunica media is also responsible for contraction and vasoconstriction of all of your arterioles. But it, it is this tunica media in the arterioles that is the main control of your blood vessels. Because there are so few arterioles compared to capillaries, arterioles form something kind of like a bottleneck to blood flow. It's like when there's one line at the DMV instead of many. So because of this, arterioles are the blood vessels that are most responsible for your blood pressure. The tunica intima of blood vessels can also be called the endothelium, but the word endothelium indicates that you're talking about the lining of all your blood vessels, all of them. And the endothelium is continuous with the layers lining the chambers of the heart. The endothelium consists of simple squamous cells, which were like eggs that were flattened. And they're flattened enough so that as blood flows through your vessels, there is no friction. You don't want bumps in the road. You want your blood to flow very nice and smoothly. More friction will equal a higher blood pressure. The tunica intima it can contain elastic protein fibers, but they're small and very diffuse. The elastic fibers are usually sandwiched in between the tunica intima and the tunica media. In this picture here, you can see the elastic, the squiggle of the elastic, and on top of the squiggle of elastic would be the simple squamous cells that are lining the lumen. You can see them a little better over here as they line the lumen.